There is a place where two states reach toward each other across a great river, where the ancient cliffs of New Jersey face the rocky heights of Manhattan, where the Hudson, wide, deep, tidal, and indifferent to human ambition, has flowed for 10,000 years. And there, suspended above it all, on four massive cables, woven from more than 100,000 individual wires, hangs one of the most extraordinary structures human hands have ever made. The George Washington Bridge carries more vehicles than any other bridge on Earth, more than 104 million in a single year. On an average day, nearly 300,000 cars, trucks, and buses make the crossing. It stretches 4,760 feet across the Hudson River. Its main span alone, the distance between the two towers, is 3,500 feet. When it opened in 1931, that span was nearly double the length of any suspension bridge that had ever been built. It has 14 lanes of traffic spread across two decks, and it stands today much as it did on the morning it first opened, a testament to ambition, to engineering genius, and to one man's absolute refusal to accept the impossible. By the early 20th century, the American city was changing at a pace that had no historical precedent. The automobile was everywhere. Millions of people were pouring into New York from every corner of the world. The metropolitan region groaned under the weight of its own growth. Factories needed freight, workers needed passage, commerce demanded speed. And yet the Hudson River, that magnificent 200-mile-long barrier between New Jersey and Manhattan, had no fixed crossing for automobiles. None. Ferries carried the traffic. Slow, seasonal, weather-dependent ferries that were wholly inadequate for a modern industrial nation on the move. Something had to be done. The idea of a bridge had floated around engineering circles since as early as 1906, rising alongside early conversations about what would become the Holland Tunnel. But for nearly 2 decades, proposals rose and fell like the river tides, competing visions, competing politics, competing egos. Engineer Gustav Lindenthal had championed a massive crossing near 57th Street in Midtown Manhattan, a bridge that would have carried 16 railroad tracks and 12 lanes of automotive traffic, topped by a tower that would have been the tallest building in the world. It was breathtaking. It was also impractical. The Army Corps of Engineers would not grant permits. Manhattan real estate developers and city planners pushed back hard. The proposal collapsed under its own ambition. It was not until 1925 that the legislatures of both New York and New Jersey finally voted to allow serious planning to begin. And it was not until a quiet, precise, Swiss-born engineer named Othmar Ammann stepped forward that the dream found its true architect. Ammann had spent years working under Lindenthal, learning, absorbing, quietly disagreeing. He saw what his mentor could not. He saw that a bridge between Fort Lee, New Jersey, and Washington Heights in Upper Manhattan was not merely possible, it was inevitable. The geography was almost perfect. On both sides of the river, the land rose in dramatic cliffs, the Palisades to the west, the rocky heights of Fort Washington to the east, meaning the bridge could achieve the necessary height above the river without requiring lengthy approach ramps built from the ground up. Maritime traffic could pass freely beneath. The footprint on each shore could be contained. Ammann made his case directly to both governors. He won them over. New Jersey's Governor Silzer and New York's Governor Alfred E. Smith both gave their support by mid-1923. And in September of 1927, ground was broken on both sides of the river simultaneously, in ceremonies that marked the beginning of one of the most complex construction projects the modern world had yet attempted. The challenges before Ammann and his team were staggering in their scope. The Hudson at this location is not merely wide, it is deep, cold, and driven by powerful tidal currents. The river bottom had to be dredged to allow large ships to pass beneath the finished bridge. Massive cofferdams, watertight steel enclosures sunk into the riverbed, had to be constructed so that workers could pour the tower foundations below the waterline in something resembling dry conditions. These were the largest cofferdams ever built at the time. The work was brutal, dangerous, and unforgiving. 3 workers drowned when one cofferdam flooded in December of 1927. A 4th was killed by a blast at the New Jersey anchorage. In all, 12 or 13 men lost their lives during construction, a number that, by the brutal standards of that era, was considered remarkably low for a project of this scale. On the New Jersey side, Workers had to blast 225,000 cubic yards of solid rock from the face of the Palisades simply to carve out the approach road. Then the cables had to be made. 4 main cables, each 3 feet in diameter, each containing 61 strands of wire rope. Each strand itself composed of 434 individual wires. In total, 105,986 wires were spun into those 4 cables. Stretched end to end, that wire would reach 106,000 miles, enough to circle the Earth more than 4 times. Teams of 350 men worked in shifts, spinning the wires on-site from reels held at a dock near the base of the New York anchorage. Each reel carried 30 miles of wire. The spinning of all 4 main cables took 10 full months. And then there was the question of the towers. Each one rises 604 feet above the river, taller than most skyscrapers of the day. They are assembled from steel sections, weighing between 37 and 40 tons apiece, held together by a combined total of nearly 500,000 rivets. The original plan, drawn up with consulting architect Cass Gilbert, called for those towers to be encased in a grand decorative skin of granite and concrete, a soaring Gothic revival statement in the tradition of the Brooklyn Bridge. Elevators would carry tourists to observation decks and restaurants at the top of each tower. It would have been spectacular. Then the Great Depression arrived in October of 1929. With devastating speed, it stripped away everything that could be cut. The stone facades were postponed indefinitely. The observation decks were abandoned. The ornamental flourishes planned for the cable anchorages, wings, fins, statues, vanished from the blueprints. The bare steel was left as it was. What happened next surprised nearly everyone. The public loved it. Critics and architects who had feared the towers would be ugly found themselves moved instead. The great Swiss-French modernist Le Corbusier, standing before those open lattice towers, declared with something approaching wonder that here, finally, steel architecture seemed to laugh. The exposed framework, its crisscrossed bracing, its raw industrial honesty, its refusal to hide what it was, became the bridge's most recognizable and beloved feature. Othmar Ammann, for his part, never used masonry towers in any of his bridge designs again. There was also a profound engineering insight embedded in the bridge's deck design. Most long suspension bridges of the era relied on heavy stiffening trusses along their sides, structures as thick as an 11-story building, weighing 13,000 pounds per square foot or more. Ammann rejected this approach entirely, working from a principle called the deflection theory, the idea that the sheer weight of a long deck provides its own resistance to movement. He designed a deck just 12 feet thick, with a weight of only 1,100 pounds per square foot. A system of plate girders underneath provided the necessary stiffness. It was an act of engineering faith, and it was vindicated completely. On October 24, 1931, the bridge was dedicated in a ceremony attended by 30,000 people, including the governor of New York, a man named Franklin Delano Roosevelt. The next morning, the first souls to cross were reportedly 2 children on roller skates, gliding out from the New York side into the open air above the Hudson. By the end of that first day, more than 56,000 automobiles had made the crossing. 100,000 pedestrians walked its length. The impact on the surrounding region was immediate and profound. Real estate values in Bergen County climbed almost overnight. Farmland became suburbs. The trucking industry along the East Coast was fundamentally transformed. What the railroad had once dominated, the long-haul truck now challenged, and the bridge made that possible. In 1962, the lower deck that Ammann had always envisioned finally opened, bringing the bridge to its full 14 lanes. Today, Interstate 95, the great spine of the American Eastern Seaboard, crosses the Hudson River on its cables. And on national holidays, something else crosses above that river. Hung inside the arch of the New Jersey Tower, a flag 90 feet long, 60 feet wide, and weighing 450 pounds, the world's largest free-flying American flag, is raised above the water. Since 2006, it flies also on September 11th, in honor of those lost that terrible morning not far away. What Ammann built was more than a bridge. It was proof. Proof that longer suspension spans were both physically and economically possible, a fact the engineering world had doubted until the moment it stood before them. Proof that exposed steel could possess beauty. Proof that a single human vision, pursued with patience and rigor through years of political obstruction, financial crisis, and physical danger, could permanently reshape a region and an entire industry. The Hudson still flows below, the cables still hold, and every hour of every day the George Washington Bridge does what it has always done, connecting, carrying, enduring. If you found this history worth knowing, subscribe for more stories of human ambition in steel, stone, and concrete.